This is Math 2 7.3 notes. That's Unit 7, Lesson 3. The title is Trigonometry. This is right triangle trigonometry. So we're going to be working with right triangles this whole unit. We already did the special right triangles, and we've already done the quadratic formula. Now we're working with what we call sine, cosine, and tangent. I'm going to label this A, B, C, right triangle, and we're going to talk about the function sine, the function cosine, and the function tangent. All of these are functions, which means they don't work alone. It's sine of A, cosine of A, tangent of A. Now, it's always going to be of an angle, tangent of A or cosine of B. You're always working with an angle, never a side, an angle when you're working with regular sine, cosine, and tangent. Okay, it's not times, it's not sine times A or cosine times A, it's sine of A, sine of an angle. Okay, you will need to know that sine of A is always going to equal opposite over hypotenuse. I'm going to abbreviate and I will write the words out in just a little bit. Cosine is always going to be adjacent over hypotenuse, and tangent is always going to be the opposite side over the adjacent side. So they're always going to be fractions that you can reduce or plug in your calculator. Okay, so you will need to have these memorized. I will give you a little tool on how to work with it. So since I'm asking for sine of A, it's not always going to be angle A, it might be angle B. In this class, we will not ever work with the right triangle when we're dealing with sine, cosine, tangent. You will do that in advanced math. Okay, angle A. Now, in reference to angle A, what is opposite, which one's adjacent, which one's hypotenuse? Now, hypotenuse is always opposite the 90. Always, so you don't have to worry about that one. Opposite versus adjacent. Opposite, you go across from it, does not share the angle A. So the BC is the opposite. Adjacent is next to it, shares the angle A with it. So AC is the adjacent. Now, I only labeled the sides here in reference to angle A. If I were to have done angle B instead, that would still be the hypotenuse, but this would be the opposite, and this side would then become the adjacent. Can you see that? Opposite, adjacent in reference to angle B. Okay, so the tool you're going to use is called SOHCAHTOA. It's not a formula, it's just like you remember PEMDAS, an acronym you use to help you do the order of operations? This is similar. S for sine, C for cosine, T for tangent. S is OH because it's opposite over hypotenuse. C is AH because cosine's adjacent over hypotenuse. Can you see the AH there? And T for tangent is O over A, which is opposite over adjacent. So use the first letters there as your opposite, adjacent, hypotenuse. Okay, moving along. I'm going to try some examples. Number 1, find sine of A as a fraction. And I did forget to say earlier, so if you don't have it with you, hit pause and grab your scientific calculator. You will need one on this lesson. If you don't have one, you can use your phone for now, but in class we will be using the scientific calculators. All right, so let's draw our right triangle. I'm going to label this one A, B, C. Hypotenuse is 45, CB is 27, and AB is 36. Those sides will be given to you. All right, now notice I have my right angle as angle B, and I did tell you guys that the right angle is not always angle C. Sometimes it's written differently. It doesn't matter. Your opposite, the 90, is still the hypotenuse. Okay, so sine of A, what I suggest you use is the SOHCAHTOA here. So you can even write it again here. SOHCAHTOA. And they're asking for sine of A. So what you do is you mark your angle A, And in reference to this, what is 27, what is 36, and what is 45? This one is the hypotenuse, so I'm just going to label that first. They're asking for sine, which is opposite over hypotenuse. So which one, I'm not even going to label my adjacent. Which of these two is the opposite? The opposite side does not share an angle with a angle with the A, so this 27 is the opposite. There's my opposite, there's my hypotenuse. So sine of A equals 27 over 45. And reduce, you can divide top and bottom by 9. 27 divided by 9 is 3. 45 divided by 9 is 5, so 3/5 is your final answer. Okay, number 2, find cosine of x as a decimal. I'm going to put in here tenths place because I want you to round your decimal to the nearest tenths. Okay, so let's draw our right triangle. I'm going to label this x, y, z. Zy is 12, yx is 16, and cx is 20. Again, those sides will be labeled for you. So, moving along, we are going to find cosine of x. So I'm going to mark my angle x. This is the angle I am working with, and I'm going to label what I need. So, cosine is adjacent over hypotenuse. Let's label the hypotenuse. Opposite the 90, this one's the hypotenuse. Which of these two is adjacent, meaning next to, meaning it shares an angle, it shares the corner x? That's 16. Can you see that? 12 is opposite, 16 is adjacent in reference to the x. Okay, so I'm going to write down cosine of x equals adjacent, which is 16, over hypotenuse, which is 20. And this one asked us to write it as a decimal, so I'm not going to reduce it. I am going to plug it in the calculator and get an answer. So 16 divided by 20 equals 0.8. It's already to the nearest tenths, so 0.8 is the answer. Okay, number 3 and 4, we're going to change it up a little bit. We're going to find the missing side. So now we're going to use what we've learned up here to find the side lengths of a triangle. Number 3. Now, we used to use Pythagorean's theorem to find missing sides, and then we learned our special right triangles to find missing sides, and now we have another tool, the SOHCAHTOA trigonometry to find missing sides. Okay, that's x, that's 12. This angle right in there is 50 degrees, and that there is enough information to find the missing side x. All right, I'm going to rewrite the SOHCAHTOA, and here's what you do. When you're looking for a missing side, again, we're looking for a missing side specifically, they're always going to give you one angle. Besides the 90, they're going to give you one angle. If they give you more than one, pick one. It does not matter which one you pick, because technically, I know this angle down here is 40. Don't need it, but I know it. So if they give you both angles, pick one. It does not matter which one. Okay, so I'm using the 50, and I'm going to label, there's a side I'm looking for and a side that's given. The hypotenuse is not given, so what is x and what is 12 in reference to this 50? X is the opposite, and 12 is the adjacent. Can everybody see that? Opposite, across from, adjacent is next to, hypotenuse. They didn't label the hypotenuse, so I'm not labeling it. So then I look here, which one's opposite adjacent? That's tangent. So this labeling tells you which function to use. Earlier they told us find sine, find cosine. Now they're not going to tell us. You have to go through and figure it out by labeling your sides. Tangent of an angle, never a side. Tangent of 50 equals opposite over adjacent, so x over 12. and I solve. I'm going to put a 1 under this to make a fraction, and I'm going to cross multiply. 12 times tangent of 50 equals 1 times x, and x is already by itself, so all I have to do is plug that into your calculator. So here's how you do it. Hit clear. 12 times, your tangent key is right there, tangent of 50, and equals 14.3. And I did forget to say it, but I want you to round to the nearest tenths place again. So x is 14.3. Let's try another one. Number 4. Okay, this is my x, this is 15, and this angle in there is 71 degrees. With these type of problems, they're always going to give you an angle, one side, and then the side you're looking for. So when you do this one, remember you put a mark on the angle. 71 is the angle that's given, that's the one I'm working with. And in reference to this, what are these two sides here? 15 is the hypotenuse. I'm going to label that one right off. What is x in reference to 71? Is it across or next to? If it's next to, it is adjacent. So I'm using adjacent over hypotenuse, so I look here to figure out which one that is, and that is cosine. So I do cosine of 71 equals adjacent over hypotenuse. So you do have to get used to labeling, because that is going to get a little difficult if you're not getting the practice. And then we put a 1 underneath and cross multiply. 15 times cosine of 71 equals x, and we're ready to simply plug it in. So I'm going to hit clear. 15 times cosine of 71 equals 4.88 da 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 da. Nearest tenths place is that 4.8 or 4.9. That is 4.9. So 4.9 is your answer. Okay. Number 5, we are going to do together in class. So I'm just going to label it for you. And I'm going to tell you right now, if you do try it on your own, that's perfectly fine. It is a little bit different from the ones I've just done with you. So there's your right triangle. I gave you the 12. You're looking for x. Don't forget to put the dot here and label which one's which. Use your SOHCAHTOA and try to find the hypotenuse. That is it for this lesson.